I can do that by looking at the men and the women separately. If I look at this relationship between TV viewing acts of violence just among the men and just among the women, I will have removed the effect of gender, right? Because if I'm looking just at men, gender won't have any effect because they're all men. That is, on this relationship, because they're all men. I'll be able to see the effect of that watching TV on violence with gender being eliminated from the equation because they're all men. Similarly, if I look at this just for women, I would be eliminating the effect of gender because I'd see the relationship, this relationship, just for women. So, here's where I've done this. My next table is exactly the same relationship, but just for men. Let's take a look. Tell me what it says. By the way, these data are all made up. Somebody new. What does this say? You know how to read a table now. You look for the weighted percentage. You know those central cells there refer to the percentage of the variable that's on top, the independent variable. And you know that the percentage difference is a measure of the strength of association between two variables. So what does this table say? I'm controlled for gender. I've taken variable out of this mess. I've now taken out one variable out. What does this say? Somebody please tell me. Somebody new. Somebody awake. Yes, sir. No, ma'am. I'm sorry. I was looking at the guy behind you. I thought it was his hand. Really. Please. Where does it say that? Where does it say that there's no relationship? How do you know that? You look at the percentage difference. What this table says is that 40% of the men, remember this is all men only, 40% of the men who watch less than 10 hours of TV per week committed less than one violent act per year, and 40% of men who watch 10 or more hours per week committed less than one violent act per year. Similarly, going down one row, 60% of men who watch less than 10 hours of TV per week committed one or more violent acts per year, and 60% of those who watch 10 or more hours committed one or more. There's no difference between column 1 and column 2. The percentage of difference is 0. We've eliminated the relationship between TV viewing and committing acts of violence. So what do we conclude? On exercise, but what's the point? Why are we doing this? We're doing this to find out if the initial association is causal or what would be the opposite of causal? No, it's not non-causal. It could be. Yes. But we call it spurious. It's phony. We want to know if that initial association is causal or spurious, causal or phony. This table tells us that initial relationship was a phony relationship. That once we control for gender, the relationship disappears. There is no relationship once we control for gender. Well, far cry from experimentation. With experimentation, we have control for all imaginable extraneous variables that could be affecting the relationship. We did that through randomization. Here we control for one. It's a plausible. Where do we go from here? Well, with this very simple example, where we go is to a general understanding of what's happening in my conversation, which I've diagrammed here. This picture is divided into two parts, top and bottom. In the top part, I show what I talked about at first, my belief that there's a causal relationship between TV viewing and aggressiveness. It's signified by the names of these two variables, one independent and dependent, joined by a solid line with an arrowhead at the end of it, and that solid line with an arrowhead indicates that there's an association, and it shows you the direction of the association. My belief was, my hypothesis, TV viewing causes aggressiveness. But then, what I did, when I asked all of the women to leave the room and looked at those four corners consisting just of men cross-classified by those two variables, was this. By controlling for gender, I saw whether gender created a spurious association between TV viewing and aggressiveness. In other words, if I had done a full analysis, I only did part of it, I would see that gender control variable is associated with TV viewing, because men are more likely to watch TV. I would have seen that because of socialization, men are more likely to behave aggressively than women. So there's causal relationships there, right? I would have been able to demonstrate that in tables. Also, I would have found this dotted line, which is what my last table represents, that there's no association between TV viewing and aggressiveness once I control for gender. That initial association, which started out causal, solid line, arrowhead, is in fact non-causal or spurious, no association. That's the logic here. In other words, when I have survey data, non-experimental data, what I want to do is I want to manipulate the data in such a way that I can introduce control variables. And I don't just pick them from the thin air. I pick control variables that other research or theoreticians or my own hunches suggest might be plausible causes of that initial association. And I introduce them one by one or all together at the same time to see what happens to that initial association. Listen to this, carefully. I may conclude tentatively that that initial association is causal if, after introducing all manner of relevant control variables, I find that an association remains. I don't know if I can say that again exactly the same way, but let me give it a go. I will conclude that the initial association is causal or non-spurious if, after introducing all manner of relevant controls, I discover that there is still an association between those two variables I started out with. So the game I'm playing is let's try to reduce the strength of that initial association by introducing controls. Let's read theory, let's think hard, let's look at past research, figure out what all those controls are, introduce them, so I have data for them, let's introduce them and see what happens to that initial association. If I reduce that association to zero, I will have explained that initial association away. I will know that that association is due to all of those control variables that I've introduced. I will know that the initial association is actually spurious and the controls are responsible for it. If, on the other hand, after introducing all of those controls, the association remains, or it's only weakened a little bit, I'm going to say, you know what, there's real causality going on here, I think. I've got to say I think. It's got to be a tentative conclusion. It's got to be a tentative conclusion because why? Why does it have to be a tentative conclusion? Yes. Because I may be missing some relevant controls that I don't know anything about. Just because somebody else hasn't thought of relevant controls and I have doesn't mean they don't exist. The beauty of experimentation is that all of those controls have already been eliminated by the process of randomization and replication of the experiment. The problem with survey research is that I can never really be sure that I've eliminated all of those extraneous variables. I can only try to be as thorough as possible and come to the conclusion with non-experimental survey data that listen, guys, you know, we've read all the research, I've thought hard about this, I've introduced every imaginable control, and it seems that the relationship is, in fact, as the original association, spurious, or partly causal, or completely causal. But I'm not 100%, and never be 100%, because there may be some other variable working in the background that I or nobody else has thought of yet. In general, we're going right to 2 o'clock. In general, to conclude that the association between an independent and a dependent variable is non-spurious or to say the same thing in a different way, to conclude that it is causal, 4 conditions have to hold. We need 4 conditions to hold. Can I actually write these out for you? No. I'll add a slide when I get home. I'm sorry. But you might as well write this down. It'll stick in your head better if you do. Here's one condition. If we're to conclude that the association between an independent and a dependent variable is non-spurious or causal in non-experimental research, the first condition that has to hold is that there must be an association between the 2 variables. We've got to see that percentage difference or correlation or some evidence that there is an association, that as one variable changes, the other variable changes. Second, we have to see that the presumed cause precedes the presumed effect in time. There are some exceptions to this, but almost always the presumed cause has to come before the presumed effect. Usually things that happen later don't affect the things that happen now. Usually. I don't want to get into exceptions to that pattern. But almost always the presumed cause happens first. Third condition for assuming that that original relationship is non-spurious or causal. When a control variable is introduced, the original association must not disappear. Or I can say it slightly differently, when a whole bunch of relevant control variables are introduced, then the original association doesn't disappear. And the fourth condition is that we have to have an explanation or theory for the associations that we've observed. Okay? We have to have some kind of an explanation or theory for why these associations that we've observed actually exist. I mean, I could have introduced shoe size as a control variable. That would have been a good one. Men have bigger feet than women on average. I could have introduced color of hair as a control variable. Okay? And maybe I would have found that that produces the association between watching TV and behaving aggressively. Would that have actually enabled me to conclude that the initial association is non-spurious, causal? It doesn't meet condition 4, does it? That would be a pretty silly theory, I think, that somehow the color of your hair influences the association between these 2 variables, watching TV and acting aggressively. Here's the problem. There's a very good biostatistician here at the University of Toronto, medical researcher, who did this a couple of years ago, 5 years ago. He took OHIP records from everybody from Ontario for the past 5 years. It was published in 2007. He probably submitted in 2006. I think the years were 2000 and 2005. Every single OHIP medical record, they were anonymized, he couldn't identify who. And he looked for all manner of associations. He had 10 million records. Okay? Well, when you have a sample that's that big, you will find all kinds of associations. One of the things he found was that people born under the zodiac sign of Sagittarius were more likely than others to be hospitalized for a broken arm. And when I read this, I realized something. What I did was I went to Wikipedia and I looked up what Sagittarius is supposed to be, like what kind of character they have. And it says in Wikipedia that a Sagittarian is somebody, among other things, who likes to take risks. And I said, could have said, or be stupid. Aha. That's why Sagittarians in Ontario are more likely to be hospitalized for breaking their arms. Because they're out there on skateboards, and they're out there doing snowboarding and all kinds of other risky activities. They're more likely to seriously break their arms and wind up in the hospital. But if I had been smart, I would have said, look, in a big sample, you can find all kinds of statistically significant associations. They will be meaningless. There's no credible theory that supports the idea, no observable set of facts that supports the idea that Sagittarians ought to be more likely to wind up in the hospital with a broken arm. And that was a biostatistician's point, that in medical research, as in all research, you can't rely just on the finding of significance between, especially when you have big samples, because your likelihood of finding significance increases with the size of the sample. You've got to have a theory that makes sense, it's credible. That's condition number 4. So condition number 1 for establishing that that initial association is caused or non-spurious, there's an association. The cause precedes the effect in time. When you introduce control variables, the initial association doesn't disappear. And 4th, that we have a theory that explains the association we discovered. If that initial association disappears once you introduce a control variable or a series of controls, then the association, the original association, is spurious. If an initial association stays the same after we introduce controls, then we tentatively conclude that the association appears to be caused. Of course, all kinds of weird and wonderful things may happen once you introduce controls. For example, the original association may remain unchanged, it may strengthen, it may weaken, it may disappear or weaken in only some categories of the control variable. It may even change direction entirely, turning from a positive association, one in which one variable increases and the other one does, into a negative association, where one variable increases and the other decreases. Controls can do all kinds of weird things to the original association. And when you do data analysis, what you're trying to do is figure out why the controls operate in that way. You're trying to explain that initial association. So data analysis is full of surprises. And accounting for the outcome of statistical controls requires a lot of creative thinking. Not statistical thinking only, but theoretical thinking. Because without the theory, none of it makes sense. Let's look at a few examples. Examples because you might get questions like this under exam. In the following 3 examples I'm going to give you, I want you to identify the independent and dependent control variables, and I want you to tell me what's going on. Tell me the story behind this. Here's the results of an American survey done 10 years ago. What this survey did, among other things, was it determined the gender or sex of the respondent, and also asked the respondents how many sex partners they had in the preceding year. This was done on adult Americans. Did you have 0 or 1 sex partner, or did you have more than 1 sex partner? Here I have the association between gender and number of sex partners. These are real data. What does it say? Quickly, somebody interpret this table for me. Look at the way it's percentage, so you know what you're dealing with percentages of. Yes? A larger percentage of males have more than 1 sex partner than females. Specifically, looking at the second row of percentages, 21% of males, we know that this is 21% of males because we see how it's percentage, have more than 1 sex partner in the preceding year. Only 10% of females. What's the percentage difference? 11. That's the strength of the association. Looks impressive. Men are promiscuous, more promiscuous than women, according to this, right? Is it true? Well, let's control for something. Let's control for marriage. Let's see if this association holds for marriage. I'm a sociologist. I believe that social facts, social institutions, influence behavior. My hypothesis is that that association is largely accounted for by whether or not a person's married. So what I've done here is I've controlled for whether or not people are married. I'm looking only here at married people. What happens to that initial association? Somebody knew. Blue, please. Yes, sir. It what? No, it doesn't. What increases? You look at the percentage difference. You look at the percentage difference to find the strength of the association. Before the percentage difference was 11. Now the percentage difference is 4. You're subtracting the cell in row 1, column 1 from the cell in row 1, row 2, from row 1, column 2. Right? Top row, those two numbers, subtract one from the other, you get 4. Bottom row, subtract one from the other, you get 4. The relationship is weaker here. What does that mean? It means that marriage has an effect on promiscuity. That if you look only at married people, then the difference between men and women in their level of promiscuity, having more than one sex partner in the preceding year, falls. There's not much of a difference, only a 4% difference. In fact, because the numbers are so small here, we're dealing with 499 men, 534 women. Actually, this difference is actually not statistically significant. There's no real difference between men and women who are married. In other words, what these tables tell us is that there is no difference in promiscuity between married men and married women. But if they're answering these questions validly, then there's a lot of difference in promiscuity between unmarried men and unmarried women. Unmarried men are a lot more promiscuous than unmarried women. But of course, the other problem with this kind of data is that it's a very sensitive question, and no precautions were taken to ensure that people would be answering honestly. There may be a lot of male boastfulness going on. Yes, I've had a lot of such charges in the past year. I mean, men are encouraged in our society to say those kinds of things, to be macho on this issue. So I suspect that this kind of analysis is not particularly useful. But nonetheless, for statistical reasons, I want to see the logic of what I've done. I have explained away that initial relationship by introducing a control. Another example. Here we have a table, made up data this time. It shows you the ratio of white to non-white and white to black income for men working full-time. So, we've got a sample of men who work full-time in Canada. Okay? Let's assume that it's randomly selected, probability sample. And what I'm interested in is in the ratio of white to non-white income for these men. That's in the first column. And then I'm also interested in the ratio of white to black income. That's in the second column. This is not a table like the ones I showed you before. You've got to infer something here. This is more complicated. So, what do I find? I find that the ratio of white to non-white income is 0.80 for all men in Canada. Okay? It means, it should be the other way. It should be non-white to white income. I'll correct that. The top of the column should be non-white to white income, not the other way. When I correct it, what this says is that for all men, non-whites take 80% of the income of whites for men working full-time. That's what that first cell says. The cell below it says what? That ratio increases to 90%. That non-white men earn 90% of what white men earn for all men born in Canada. Here, in other words, I am controlling for nativity, it's called, namely where they're born. Okay? In other words, being born in Canada seems to explain some of that ratio, right? The ratio actually gets higher. Men, white and non-white men in Canada are more equal if we're looking only at people born in this country. If we go down yet another step, we see all men born in Canada with university education. For them, we find that the ratio is equal. There's no difference between non-white men and white men. So we might have started out with the idea that there is racial discrimination in Canada against non-white men, against non-whites. But if we control for nativity, and university education, we find that there is no such inequality. In other words, that if you have a university education and you're born in this country, regardless of whether you're white or non-white, you can expect the same income. However, and I know some of you have to go to another class, just go quietly. I'll continue for another couple minutes if I may. If now in the second column you look only at black income to white income, remember I said it the opposite way here by mistake. What we find, if you want to return to this table, is that the percentages move in the same direction. As we introduce control, they become more equal. However, there's still greater inequality among the black-white comparison than the white non-white. Okay, the numbers in the second column are lower than those in the first column. So, in other words, what I've done here is I've controlled different ways to discover that there is no racial discrimination going on if I compare whites and non-whites, but there is racial discrimination if I compare whites and blacks. Okay? There exists even after control. I've still got black men with university education who were born in Canada making 90% of what white men are making with the same characteristics. And the last example I want to give you concerns, again, income ratio. I want you to remember this is not the kind of table I showed you earlier. You've got to infer what's going on in the table. It could be derived from this. It says at the top, on average, full-time workers, among full-time workers in this country, men earn about 3/4 of what women earn. But then what I've done here is I have introduced marital status as a control. And what do I find? I find, and these are real data items, I find that for never married women, the income ratio, the ratio of what women earn to what men earn, is 0.919. In other words, women who are not married, compared to men who are married, earn about 92% of what men earn. For married women, it's more like 65%, 0.649. What this suggests then is that marital status accounts for much of the income gap between women and men. Once women get married, in other words, they pay an income penalty, in a sense, because they have to, or generally, they don't have to, but they generally take care of kids in the home, sacrifice their education and their career in order to do that. It turns out that their income relative to men falls after marriage. So what I've done here is I've specified the relationship. Rather than simply saying gender is responsible for the difference in income between women and men, I'm now able to say, after introducing marital status as control, that the reason, or at least part of the reason why there is a gender gap between women and men income is that after marriage, women suffer an income decline because they're out of the labor force. Understand? I've introduced the control, I can say something more precise. Ladies and gentlemen, thank you very much. Good luck on the final exam.